Hey kids, welcome to Fun Learning. Today we will be learning about formation of landforms. In this video you will learn about part of the Earth, tectonic plates, divergent, convergent, and transform boundaries, and hotspots. You will also be able to identify how movements of tectonic plates change Earth's surface. You will be able to summarize how movements of tectonic plates have influenced climates and life on Earth. And also, describe the supercontinent cycle. Let's begin with landforms. What are landforms? Landforms are the natural structures or features on Earth's surface. There are many different types of landforms found on the Earth. Landforms are the natural structures or features on Earth's surface. How landforms came to be. Earth is mostly covered in water. There are landforms on the remaining parts of the Earth. Landforms are natural features on the Earth's surface. Examples: mountains, hills, plains. Earth's landforms and continents were formed through the theory of plate tectonics. Plate tectonics says that the Earth is made up of several large, slow-moving slabs or plates. The continents and ocean floors form the tops of the plates which move and carry the continents and ocean floors with them. 13 major tectonic plates of the world. Scientists believe that long ago the Earth's landmasses made up one giant supercontinent called Pangaea. Scientists believe that long ago the Earth's landmasses made up one giant supercontinent called Pangaea. Now the world is divided into 7 continents. Scientists believe that forces inside the Earth caused Pangaea to break apart. Continental drift is a theory that explained how continents shift position on Earth's surface. Set forth in 1912 by Alfred Wegener, a geophysicist and meteorologist, continental drift also explained why look-alike animal and plant fossils, and similar rock formations, are found on different continents. This how it started. 225 million years ago. There is one single continent, Pangaea. Then Pangaea is divided into 2 parts. Laurasia and Gondwana in 150 years ago. After 100 million years ago it divided into 7. This is how it looks now. Earth is made up of layers similar to an apple. Earth has a crust, mantle, core just as an apple has skin, meat, and a core. Earth's crust is 10 to 25 miles thick. Earth's mantle lies just below the crust and is 1,800 miles thick. The mantle is made of hot, rock-like materials. The core is broken into 2 parts, the inner core and the outer core. The inner core is solid and the outer core is molten or melted rock. The liquid outer core surrounds the inner core and is believed to be composed of iron mixed with nickel and trace amounts of lighter elements. Recent studies suggests that the innermost part of the core is enriched in gold and platinum while also containing nickel and primarily iron. Extreme heat from the core causes the mantle to create pressure on the crust, forcing the crust in some places to rise. As the crust rises it pushes large blocks or rock upwards and forms mountains or plateaus. A portion of the Rocky Mountains formed this way. The internal structure of Earth. Mountains can also be formed when one plate over another plate. The Earth's plates are constantly moving even today. The movement of plates sometimes shakes the Earth's surface, causing an earthquake. Earthquakes are common around faults. Fault is a break in the Earth's crust where movement occurs between the plates. The San Andreas Fault in California is one of the most well-known faults in the world. Most faults are not visible, but the San Andreas Fault is visible. Supercontinent. One way that continents change shape is by breaking apart. Rifting is the process by which a continent breaks apart. Terrain: a piece of lithosphere that has a unique geologic history and that may be part of a larger piece of lithosphere, such as a continent. Continents change not only by breaking apart but also by gaining material. Most continents consist of cratons surrounded by a patchwork of terrains. Terrains become part of a continent at convergent boundaries. When a tectonic plate carrying a terrain subducts under a plate made of continental lithosphere, the terrain is scraped off of the subducting plate and becomes part of the continent. Terrains become part of a continent at convergent boundaries. When a tectonic plate carrying a terrain subducts under a plate made of continental lithosphere, the terrain is scraped off of the subducting plate and becomes part of the continent. Modern climates are a result of past movements of tectonic plates. When continents move, the flow of air and moisture around the globe changes and causes climates to change. Geologic evidence shows that ice once covered most of Earth's continental surfaces. As continents began to drift around the globe, however, global temperatures changed and much of the ice sheet melted. As continents rift or as mountains form, populations of organisms are separated. When populations are separated, new species may evolve from existing species. Supercontinents cycle: the process by which supercontinents form and break apart over millions of years. Pangaea: the supercontinent that formed 300 million years ago and that began to break up beginning 250 million years ago. Pangaea: the single, large ocean that covered Earth's surface during the time the supercontinent Pangaea existed. Using evidence from many scientific fields, scientists can construct a general picture of continental change throughout time. Several times in the past, the continents were arranged into large landmasses called supercontinents. Supercontinents broke apart to form smaller continents that moved around the globe. Eventually, the smaller continents joined again to form another supercontinent. The process by which supercontinents form and break apart over time is called the supercontinent cycle. Breakup of Pangaea. About 250 million years ago, during the Paleozoic era, Pangaea began to break into two continents, Laurasia and Gondwanaland. Laurasia became the continents of North America and Eurasia. Gondwanaland became the continents of Africa, South America, India, Australia, and Antarctica. Laurasia became the continents of North America and Eurasia. Gondwanaland became the continents of Africa, South America, India, Australia, and Antarctica. Pangaea breaks into 7 continents in 335 million years. Slowly, the continents moved into their present positions. As the continents drifted, they collided with terrains and other continents. New mountain ranges, such as the Rocky Mountains, the Andes, and the Alps, formed. Tectonic plate motion also caused new oceans to open up and caused others to close. Positions of the continent present with red. Geologist Alfred Wegener noticed similar rocks and fossil remains were found on continents which seemed to fit together. He called this super-continent called Pangaea. In 1912, Wegener published the first version and died defending his theory. The large landmass that included shape of the continents fit together like puzzle pieces. Wegener was not the only one to notice the fit of the continents. In 1858, Antonio Pellegrini depicted Africa and South America connected. He was one of the first scientists to publish maps depicting the apparent fit of the continents. Fossil evidence. Mesosaurus was incapable of swimming across a large ocean. Same fossils in different continents. Rock evidence. Mountain ranges. Same rock, different range. Existing mountain ranges separated by vast oceans contain rocks of identical mineral content. Another supportive evidence was glacial scars. Same scars, different continents. Location of coal deposits. Coal deposits have been found in temperate and polar regions. However, coal is formed in tropical regions. Why didn't people believe in continental drift? People couldn't imagine how the Earth could be millions of years old. People couldn't imagine a force great enough to move the continents. This continent drift led to the plate tectonics. The theory of plate tectonics, boundaries, stresses, and faults. What is the theory of plate tectonics? What are the three types of plate boundaries? Let's find out what does plates means. The Earth's crust and upper mantle, lithosphere, are broken into sections called plates. Plates move around on top of the mantle like rafts. A section of the lithosphere that slowly moves over the asthenosphere, carrying pieces of continental and oceanic crust. What is the theory of plate tectonics? The theory that pieces of Earth's lithosphere are in constant motion, driven by convection currents in the mantle. Plates move slowly in different directions. Cause different geologic events like earthquake, volcano. What makes the plates move? Convection currents in the mantle move the plates as the core heats the slowly flowing asthenosphere, the elastic, plastic-like part of the mantle. This diagram illustrates the whole process. Plate boundaries. The edges of Earth's plates meet at plate boundaries, extended deep into the lithosphere. Fault are breaks in Earth's crust where rocks have slipped past each other. There are three types of plate boundaries. What are the three types of boundaries? Divergent boundaries, convergent boundaries, transform boundaries. A different type of plate movement occurs along each type of boundary. A plate boundary where two plates move away from each other are known as divergent boundaries. Rifting causes seafloor spreading. How is the rock pulled at divergent boundaries? Rock gets thin in the middle as it is pulled apart. This stress is called tension. Let's see how. A normal fault is a break in Earth's crust. Rock drops down as it breaks. What happens next at divergent boundaries? A geologic feature or event may form rift valleys on continents. Here are some helpful hints. Divergent is like dissecting or dividing. If you pull warm bubble gum or silly putty, it will thin in the middle until it is stressed so much that it breaks. Happens on land and under H2O. This how it dissect into two parts and magma erupt from the center. Features of divergent boundaries. Mid-ocean ridges. Rift valleys. Fissure volcanoes. How is the rock pushed at convergent boundaries? A plate boundary where two plates move towards each other. Boundaries between two plates that are colliding towards each other. This stress is called compression. Convergent boundaries. places where plates crash, or crunch, together or subduct, one sinks under. The Earth is divided into 3 parts, or we called layers. Let's look inside the Earth. The parts named is crust, mantle, core. Then crust is divided into oceanic and continental crust, core into inner and outer. Heat transfer from the core to the mantle produces slow convection, a mode of heat and mass transfer of the mantle material. This is what causes the Earth's plates to move, in the order of centimeters per year. The force from the transfer of heat at the mantle boundary pushes the crust around in different directions. This is what causes the crustal plates to move around. The continental crust is the solid masses of the continents. This is composed primarily of granite. The oceanic crust is a thick mass of basalt rock which lies under the ocean floor. The oceanic crust is a thick mass of basalt rock which lies under the ocean floor. Tectonic plates are the dozen or so plates that make up the surface of the Earth. Think. Well, Hawaii is located on the Pacific Plate. Plate tectonics is the geologic theory that combines the concepts of seafloor spreading and continental drift to explain the large-scale movement of the Earth's crust. In a divergent boundary, 2 plates are moving apart and new crust is created by magma pushing up from the mantle. This is how the 2 plates are moving apart and new crust is created by magma pushing up from the mantle. A convergent plate boundary is where crust is destroyed as one plate slides under another. There are 3 types of convergences. In an oceanic convergence, 2 oceanic plates converge, come together, and one is usually subducted under the other. In the process, a trench is formed. In a continental convergence, 2 plates meet head-on and resist motion. As a result, the crust tends to be pushed upward, forming mountains. In an oceanic continental convergence, an oceanic plate pushes into and subducts under a continental plate. Typically, the continental plate is lifted up and a mountain range is created. This type of boundary is more commonly known as a fault. While most transform faults are found on the ocean floor, a few, such as the San Andreas Fault in California, occur on land. A transform plate boundary is where 2 plates are sliding horizontally past one another. Hawaii is geologically a unique place. A hotspot is an area in the middle of a crustal plate where volcanism occurs. Over millions of years, molten magma breaks through the crust and produces undersea volcanoes. Some of these volcanoes build up to the surface of the ocean and become islands. Over the course of millions of years, the plate may move across the hotspot and the original volcano becomes extinct. A new volcano will begin to form in the area of the hotspot. The Hawaiian Islands are a perfect example of how the plate has moved over the hotspot and produced the chain of islands. The newest volcanic seamount in this series is Loei, lying 45 kilometers, 28 miles, east of the Big Island's southernmost tip, rising more than 2,450 meters, 8,000 feet, above the seafloor and 969 meters, 3,178 feet, below the surface. Molten rock, or magma, rises in convection cells like water boiling in a pot. The left side shows the traditional view of a hot spot is a plume of magma rising from the Earth's core. The right side shows another theory of a hot spot originating at a much shallower depth. This theory describes hot spots not as plumes from the deep, but mostly stirrings in the upper mantle, its top 400 kilometers, caused by the movements of the crustal plates and surface-based cooling. We have seen the connection between volcanoes and plate tectonics. Is there a connection between earthquakes and plate tectonics? Then what's the connection? The black dots on this map of the world depict where earthquake activity is occurring. You can see that, as with volcanoes, the earthquakes are not randomly distributed around the globe. Instead, they occur in linear patterns associated with plate boundaries. Note this diagram of earthquake distribution closely resembles the Pacific Ring of Fire distribution of volcanism. Firstly, what are hotspot volcanoes and how do they form? A hotspot is a location on the Earth's surface that has experienced active volcanism for a long period of time. The source of this volcanism is a mantle plume of hot mantle material rising up from near the core mantle boundary through the crust to the surface. See the diagram. A mantle plume may rise at any location in the mantle, and this is why hotspot volcanoes are independent from tectonic plate boundaries. The Hawaiian island chain are examples of hotspot volcanoes. Hotspots commonly form volcanic island chains, like the Hawaiian Islands. These result from the slow movement of a tectonic plate over a fixed hotspot. Persistent volcanic activity at a hotspot will create new islands as the plate moves the position of the old volcanic island from over the hotspot. Therefore, at one end of the island chain you see the youngest, most active volcanic islands, directly over the hotspot, and along the island chain the extinct volcanoes become older and more eroded. See diagram. This way geologists can use hotspot volcano chains to track the movement of the tectonic plate through time. Where do earthquakes form? We know there are three types of plate boundaries: divergent, convergent and transform. Movement and slipping along each of these types of boundaries can form an earthquake. Depending on the type of movement, the earthquakes occur in either a shallow or deep level in the crust. The majority of tectonic earthquakes originate at depths not exceeding tens of kilometers. In subduction zones, where old and cold oceanic crust descends beneath another tectonic plate, deep focus earthquakes may occur at much greater depths, up to 700 kilometers. These earthquakes occur at a depth at which the subducted crust should no longer be brittle, due to the high temperature and pressure. A possible mechanism for the generation of deep focus earthquakes is faulting. Earthquakes may also occur in volcanic regions and are caused there both by tectonic faults and by the movement of magma, hot molten rock, within the volcano. Such earthquakes can be an early warning of volcanic eruptions. I hope you have learnt a lot. Thanks for watching.